All right, it is chapter 9A, concept 5. I know it says concept 7, but just ignore that. We're going a little bit out of order because today we are going to talk about solving quadratics using factoring. Yes, factoring is awesome. Factoring is what you learned about in chapter 8B. I believe it was concept 3. 8B concept 3 and also concept 4 actually. There's a couple of factoring things in chapter 8B. So if you don't remember factoring, or if I'm saying that and you're like, what is she talking about? Remember, you can always go back to 8B and watch those videos again to help you remember everything you need to remember about factoring. Because today we're going to use factoring to help us solve the quadratic. And when we're talking about solving a quadratic, what are we looking for? Well, we're going to, of course, look for solutions. Solving means what's the solution? But wait a minute, solutions also means roots and zeros and x-intercepts. So everything that we do today using factoring is all going to be about finding solutions, roots, zeros, x-intercepts, all of those, one and the same, okay? And the thing that we're going to add on to factoring that allows us to use factoring as a tool to find the solutions is what we call the zero product property, or the ZPP. ZPP, the zero product property. Basically what the zero product property says, if you have two things that are being multiplied together, and when you multiply them together it equals 0, then that means that one of these, and maybe both of them, have to be 0. So that means you can take this and set it equal to 0, and you can take this and you can set it equal to 0, and it allows you to solve. Okay? And we'll take a look at more in detail what that means and how that's helpful to us. All right, so before we dive in, I want you to understand the steps in using factoring to solve quadratics. The first thing you're going to want to do is factor the expression using grouping. Again, if you need help with factoring by grouping, that's 8B concept 3. And then you'll also need to know 8B concept 4 for a little bit later on in this lesson. But that's the two lessons that you want to make sure you go back and check out if you need to. You're going to set each of these factors equal to 0. This is because of the ZPP. The ZPP tells us that we're allowed to do that. Then you're going to solve each equation separately. Well, if you have two factors and you solve them separately, that means you are going to end up with two solutions most of the time. Because remember, there is a scenario where we might only have one solution. So let's take a look and put all this together with some examples so this begins to make a little bit more sense. Shall we? We shall. All right, so taking a look at number 1. Remember back in chapter 8B, we factored using the x. And if the x makes sense to you, then by all means, keep using it, okay? I'm not going to go over it again because we did that back in chapter 8B. But if you struggled with the x a little bit, one thing that you can do is you can say, all right, I know I have to multiply a times c, whatever that is. So positive 4 times positive 1 is positive 4. That would be the top of your x. Remember when we would take both of the sides and we'd put them all the way up at the top? All right, well, you can just say a times c is this, factor that, factor whatever that is, and we want two factors that are going to be negative 4. Well, in order to get a positive when I multiply, they're going to have the same signs. So I could use 1 and 4, or I could use 2 and 2. 2 and 2 will work to make negative 4 if I have negative 2 and negative 2. When I combine those together, it will give me my middle term, negative 4. The reason that's important is because now the whole purpose of doing that is so we can split this middle term into negative 2x and negative 2x using that factor pair that we just found. We're going to bring down our last term and we're going to bring down our first term because those stay the same. They are not going to change at all. Then we are going to group, and I have a group here and a group here. Once we group them, we can pull out our GCF. So from 4 and 2, the common factor is 2. X squared and x, I can pull out one of the x's. And then what's left over? Well, I'm going to have to divide to find out. Divide and divide by 2x. So let's see, 4 divided by 2 is 2. X squared divided by x, one of those will cancel, and there will be one x left over. Negative divided by a positive is a negative. 2 divided by 2 is 1. X divided by x is 1. So there we have it. 2x minus 1 is what's left over. Now here, 2 and 1, there's not really a common factor. An x and no x, I can't even factor out an x. But I still have to factor something out. So I'm going to take this negative and factor out just a negative 1. That works. So what's left over if I divide by negative 1 to both of these? Well, negative divided by a negative is a positive. 2 divided by 1 is 2. X divided by 1 is just x. Positive divided by a negative is a negative. 1 divided by 1 is 1. And that's what's left over, which works because I have my twins, which are 2x minus 1, and I have my loners, 2x minus 1. Hey, look at that. They ended up being the same thing. Well, I know that this is equal to 0 because when I first started, it was equal to 0. And so my ZPP says I can take this factor, 2x minus 1, and I can set it equal to 0. And I can take this factor, 2x minus 1, and set that equal to 0 as well. Now let me solve those. Check it out. They're exactly the same. Cool, huh? So the thing you need to know is when you have two factors that are exactly the same, you only need to solve one of them. If they're different, solve both. But if they're exactly the same, just solve one. That's fine. Let's take a look at another example. Let's do number 2. We've got A is 1. So we're going to do A times C. This number times this number, and it gives us positive 4. And I need factors of 4 that will combine to give me negative. Hey, we just had this one. Negative 2 and negative 2. All right, let's take a look. I'm going to split this middle term into negative 2x, negative 2x. Bring down my last term, bring down my first term. Now I have groups. And x squared and negative 2x, my greatest common factor is x. Leftover would be x minus 2. My first term is negative, so I'm going to have to factor out a negative here, and my GCF between 2 and 4 is 2. Leftover, I have x minus 2. So my twins are x minus 2. My loners are x minus 2. And of course, it's all equal to 0 because that's what I started with. Now, according to my ZPP, I can take these two factors and set them equal to 0. But since they're exactly the same, I just have to do one of them. X minus 2 equals 0. I just picked it, and I set it up equal to 0. So now when I solve for x, x equals 2, there's my solution to that quadratic. That means the x-intercept, there's only one x-intercept. It crosses the x-axis one time at x equals 2. Okay? Let's take a look at number 3. Why don't you pause the video, give this one a try, factor it, set each factor equal to 0, solve for x, see what you come up with. Come on back when you think you've got it. How did it go? Were you able to get x equals 3? If you didn't, pause the video, take a look at the work that I did, and see what was different than yours. But if you got it, let's keep moving along. Let's do number 4. All right, so we've got 1 is A and C is 42. So if I do 1 times positive 42, that gives me positive 42. Factor that. 1 and 42. 2 and 21. Yeah. 3 and 14. 4, no. 6, no. 7. 7 goes in, oh no, 6, yeah, 6 goes in times 7. 6 times 7 is 42. And if this is positive and this is positive, it will give me positive 13. So there's my magic pair. That's the one that I want. I'm going to split this middle term to be positive 6x and positive 7x. Keep my last term and keep my first term. So now I'm going to group them. Group, group, and factor out my GCF. In my first group, my GCF is x. Left over, I have x plus 6. In my second group, my GCF is plus 7. My leftover is x plus 6. My twins are x plus 6. My loners are x plus 7. And of course, that all equals 0. So my ZPP says that my solutions will be x plus 6 equals 0 and x plus 7 equals 0. So solve. And my solutions are x equals negative 6 and x equals negative 7. Notice this time I had to solve 2 of them because they weren't exactly the same. That means that this equation will create a parabola that crosses the x-axis in 2 places, at negative 6 and negative 7. Wow, that's a pretty skinny graph. All right, let's do number 6. So A is 1 and C is 6. 1 times 6 is 6. Factor that and I've got 1 times 6. Now you might think that 1 and 6 would work to get 5, but they only work if their signs are different. In order to get a positive 6 when I multiply, their signs have to be the same. They have to both be positive or both be negative. So I can't use 1 and 6. Let me keep going. 2 and 3. Hey, if these are both positive, that'll give me a positive 5. So I'll use that to split my middle term. Plus 2x plus 3x. Keep my last term, keep my first term. Now I'm going to group and group. X times x plus 2 is my leftover. Factor out a 3. And x plus 2 is my leftover. My twins are x plus 2 and my loners are x plus 3. Of course, all equal to 0. Now my ZPP says take each of these factors and set them equal to 0. So x plus 2 equals 0 and x plus 3 equals 0. Solve those two. Oops. X equals negative 2 and x equals negative 3. So this parabola crosses the x-axis in 2 places. Why don't you pause the video, try number 8 and number 9, and come on back and I'll show you how they're done once you think you've got them. Whew, that's a lot of work. I hope that you're starting to pick this up. I promise that it will get easier and easier the more you practice. So go ahead and finish up number 5 and number 7, and then you can come on back for part 2 to see some more examples.